So 40, we basically have to do the same thing as 35, except now we have g of x for cosine of x. Alright, so part A wants us to figure out the minimums and maximums. So the first thing I want to do is record or graph this. So I'm going to come in here, clear this out. It's a trig function, so I'm going to do 4 times cosine of x. Then I'm going to hit graph, and it's a trig function, so I'm going to change the zoom. Let me just do the window. It's going to go from -5 to 5, and then we'll go from -6 to 8. Whoops. Do you guys understand what Mr. Adams is doing when I say -6.28? What is that value? Do you know that off the top of your head? If you were to divide that number in half, what would it be? 3.14. Does that remind you of anything? Pi. So I'm setting my window from -2 pi to pi. Okay? Alright, so that's cosine. Now what we want to do is we want to kind of figure out where the mins and maxes are. So right at x equals 0 there's a min. And does anybody remember the period of cosine? When does a cycle repeat itself? Every 2 pi. So we're going to have maxes. Oh wait, no, part A wanted us to determine the is it increasing or decreasing. So this is going to be a little more challenging to define because there's a pattern where it increases and decreases, right? So for 40, it's increasing from here to the next peak, right? So what are those values? Well, it looks like from pi to about 2 pi. So it increases from pi to 2 pi, but when does it increase again? Well, that looks to be at about 3 pi. So from pi to 2 pi it increases, and then at 3 pi, from 2 pi to 3 pi it decreases. So let's start with the decrease. We'll start at 0. It decreases from 0 to pi, and then from pi to 2 pi it increases. Then it increases or decreases from 2 pi to 3 pi. And if you had to guess, what would you write up here? 3 pi to 4 pi and so on and so forth. Is there a shortcut way? Because it looks like it's going to keep doing that forever, right? So how would you do that? Could you say 2k minus 1 times pi, comma 2k pi? Because it's always like 1 and 2, 3 and 4. The next one would be 5 and 6. So it's always like an odd number and then the corresponding even number. And so this would be like an odd number and then the corresponding even number. And then this one would be the flip-flop of that. This one, it always starts with the even number. So it'd be like 2k times pi, comma 2k plus 1 times pi, where k is an integer. Does that make sense? So if I plug in 1 for k, I get 2 times 1, which is 2, minus 1, which is 1 pi. Then when I plug 1 in for k again, I get 2 times 1, which is 2, and that's pi. Here, if I plug in 1, I get 2 pi. Here, if I plug in 1, I get 3 pi, and so on and so forth. So that's a general way to write it, right? Get used to seeing this. Anytime we say 2k plus 1 or 2k minus 1, that's Mr. Adams' fancy way of saying an odd number. Whenever you see Mr. Adams write down 2k, that's a fancy math way of saying an even number. So that's just part A, the increasing, decreasing part. Part B wants to know the minimum and maximums. Well, the maximums, if we pull up the graph, the maximums occur at 0 and 2 pi. So the maximums occur 0 to pi. Where do you think the next one will occur? 4 pi. How could I write that? Those are even numbers times pi. How could I write that? How about 2k times pi? So when I plug in 1 for k, I get 2 pi. If I plug in 2 for k, I get 4 pi, and so on and so forth. Now the minimums, those are going to occur at pi, 3 pi. How would I write that? 2k plus 1 times pi. And those are all the odd numbers times pi. Wait, that's actually part C. Oh, is this symmetrical? This is part C. I totally skipped B. B is it odd, even, or neither? Well, if we look at the graph, is that odd, even, or neither? Odd means it reflects over the origin. Even means it reflects over the y-axis. Is it either one of those? Because if not, then it's neither. So look at the graph. Is that symmetrical about the origin? How many think that's symmetrical about the origin? Raise your hand if you think it is. Okay, how many think it's symmetrical about the y-axis? Raise your hand if you think it is. How many of you guys think it's neither? Raise your hand. Okay, it is even. Now we can verify that with the table of values, because if I go and look at the table of values, when I plug in -2, I get -1.166. I get that same value when I plug in +2. Remember, that's another property of an even function. If I plug in a certain number for x, I'll get a y value. If I plug in the opposite of that value for x, I'll still get the same number. For example, 1, when I plug in +1 for x, I get 2.16 for y. But when I plug in -1 for x, I get positive 2.1612. So I get the same value whether I plug in a -1 or a +1. That only works on even functions. Okay? And then part D says, compare this to one of the 12 basic functions. So I'm going to compare g of x, which is 4 cosine of x, to f of x, which is just cosine of x. So I'm going to do that graphically. So this is my original function graphed, and then now I'm going to compare it to the basic, or I'm going to compare that to the one of the 12 basic functions, which is just plain old cosine of x. So looking at the equation or formula itself, what's the difference between the two? This one I'm multiplying by 4. Now how would that look mathematically? Well, let's look at the table of values. What do you think the relationship is between this number I get 4, and this number I get 1. Huh? All of the y values are multiplied by 4. Now what will that look like graphically? It's just stretching it vertically. How many units? 4 units. So technically the amplitude is increased to 4, but we're going to say stretched vertically by scale factor of 4. Okay, that's a little more formal way to say it, okay? So that 4 just stretches it vertically. It's like grabbing it and just doing this, stretching it. Any questions?